Okay, so one way to measure the rate of respiration is by using something called a respirometer, which is this apparatus we see in front of us here. Now, the respirometer has three main components. It's going to have a boiling tube on this side here where it says B, another boiling tube where it says A. What's happening here is if you look closely, ooh, let's just move down. See here, it says plastic or metal cage containing seeds. So this is measuring the respiration rate of seeds. Now, what this is actually going to measure is the amount of oxygen that's going to be taken up into test tube B. So if I was to just show this, the movement of oxygen would start here, and this liquid here would actually be moving up this capillary tubing. This piece of apparatus in the middle over here is known as a manometer, not a manometer, not something to measure how manly someone is, but a manometer. So that's something that just measures like pressure changes and things like that. So what's happening is oxygen's being taken in by the seeds. So I'll just draw that O2. That's terrible. Let's zoom in. Can't even zoom in. There we go. So O2 is going to be taken in by the seeds. And now you're thinking, well, if it takes an O2, then why isn't CO2 being released? Okay, why is that not happening? Why is that then not causing the pressure to go whoop down this way instead because CO2 is being released? Well, there's a few things. There's actually one thing that's preventing that, and that is this sodium hydroxide solution here. So the sodium hydroxide solution is actually the thing that absorbs the CO2 leaving. Um, so yeah, what you've got on the left hand side is the same setup, is just without the without the seeds. So there's no respiration occurring here. So it's a bit like a control tube, but at the same time, because nothing's happening, the fluid in the manometer will happily be moving up this way because of the amount of reduced oxygen in the air in test tube B. Um, so that's pretty much it. The other thing is here they say they've got a filter paper. So the reason for the filter paper is to ensure that, and I'll write it out. So I'll write it in black in this. So ensures. Let's make this box a bit larger. Oop. Okay, let me. Sorry, 1 second. Sorry. Uh, there we go. That'll do. So maybe this paint wasn't a good idea. Maybe next time I just won't use it. So forget it. Ensures the potassium hydroxide solution. K potassium is K, OH is hydroxide solution. So that's AQ is absorbed into the surrounding air as to optimize CO2 uptake from respiring organisms. In this case, the respiring organism is the seeds. Now, will this let me move this over, or am I forever destined to? Ah, there we go. There we go. So that's the God's sake. There we go. That's the role of that. I think that covers everything. The syringe there is to just incorporate more air into the system in case the manometer fluid gets past this point here. Or actually, well, you don't want to get past this point here. You can also figure out the volume of oxygen that's been um, used up by measuring the amount of centimeters it moves in a certain amount of time. So let's say it moves 2 centimeters in 10 minutes, which is fairly a decent normal rate for this amount of seeds. So you know that it's moved 2 centimeters, and also you should know the capillary tubing radius or diameter. So let's say diameter of the tubing, it's or what have I done to myself? Let's say it's 0.5 millimeters. So knowing that, and they'll probably give you the equation in the exam to figure out the area of a cylinder. You could figure out the amount of oxygen, volume of oxygen being taken up. And that's pretty much it.